Here's a harder problem that gives a use of the master formula for the tangent line to a graph. What we've got, it's a classic backwards problem. Here's the forwards version of the problem. It would be take some point on the graph, find the tangent line through that point to the graph, and show that it goes through a certain target point. That wouldn't be too bad. You just calculate the tangent line and then plug in the coordinates to see that it actually that actually goes through the point. But here's a backwards version. We have the target point given, and we want to find the tangent lines to this curve, not this one, not this one, not this one, something like here, and something like maybe way up here. We want to find these two tangent lines that actually go through that point. So there's a few ways to do it, but here's one way that's somewhat straightforward. So we just pretend we're doing the forwards problem, but we put in a letter where we would have a number. And that letter is the A. So the mystery is, what is the A? What is the special x value? Like here and maybe here. It looks like maybe close to 1. I don't know. What is the mystery A, which will actually yield the correct tangent lines? So we're going to plug in the formula for, we're going to take our universal formula for the tangent line, and we're going to let A be a letter as well as x and y, and they're going to have slightly different roles here. Okay, so first of all, here's our f of x. Okay, so we're going to do this in a second, but let's prepare. F of x, or sorry, f prime of x is going to be 2x minus 1. So f prime at our mystery special point A is just going to be 2a minus 1. So that can be plugged into here. And f of a we can get by just plugging a into here. We're going to get something with just a's and x's on the right-hand side. Explicit formula in terms of a's and x's. Okay, let's see if we can do that. I don't have a lot of room on this picture. Let's do it over here. Okay, so f prime, or sorry, we're going to plug everything into here. Here's going to be our universal formula for all the tangent lines to this function. It's going to be very cool, but a little complicated. It's going to be a squared minus a, because that's the height at our mystery point A. We're just plugging in a into here. Just as if it were a number, we'd plug into there for here. Plus the quantity 2a minus 1 times x minus a. Whoa, that's kind of funky because it's got the a's and x's. So remember, what you want to think of is if you selected a particular a, then that would lock in these as numbers, and you'd get just a formula for the function, the straight line, y in terms of x with just numbers. But we actually now are going to take the opposite perspective. The one thing we know when we want to be true about this line is we want it to go through minus 2, minus 3. So what we can do is we can actually say, okay, we want this to be true where y is minus 3 and x is minus 2. Well, you can barely see those x and y. X here and y here. So I can plug those in, and then I'll get one equation for my mystery A. It's pretty cool. So I'm just going to plug those in, and then this is going to be minus 2 minus A. Okay, now we just have to simplify a little bit. Minus 3 equals a squared minus a plus, and now I'm going to have to carefully do this out. So we're going to get a minus 2a squared. We're going to get a minus 4a plus a, so minus 3a, and then a plus 2. And I'm going to put everything over on one side. So 0 is going to be, let's see, we've got minus a squared from this, and then minus 4a, and then I'm adding 3 to both sides, so plus 5. And I hate having minus in front of my... Aha, there we go. Ooh, you can't see that 0, can you? There we go. Oh, I can move the camera. That's great. Okay, so we've got a quadratic in A. And we know how to solve this, guys. Hopefully it factors, but there's no guarantee. We could have weird numbers come out here. Now that I've used this up, you can always rewind the video if you forgot where that came from. I'm going to go over here, since I don't have a lot of room in this video, this style of video. And you know what? That does factor. That's A plus 5 a minus 1. And in fact, my guess that I didn't actually know what the answer was ahead of time. My guess that it looked like the tangent line right at 1 would work is actually true. So a equals minus 5 and a equals 1. This is the answer. We're done. Because remember, the mystery thing was, what is the magic a value? What is the a to plug into our master formula, master tangent formula, that when we do that, we'll get a line that will actually be satisfied, whose equation will be satisfied, at minus 2 comma minus 3. And so minus 5 worked and 1 worked. So yeah, we got this one, and then it was something pretty far over to the left and up, and not even much further than I indicated over here, I guess. It's actually kind of shooting off, way off to the left and up. And so that's an example of why this master formula can be useful for somewhat more sophisticated problems.